Okay, let's take a look at quadrilateral triangles and other questions. So here we need to show that triangle PQR is a right triangle. So what does that mean? A right triangle means that two of the sides meet at 90 degrees. Or another way of saying it is that two of the sides are perpendicular. And when we hear perpendicular, we know that that means that the slopes of those two perpendicular lines will be negative reciprocals, or the product of the two of them will be -1. So really what we need to do is we need to see what the slope of this line is, what the slope of this line is, and what the slope of this line is, and then see if any of them are negative reciprocals. And if they are, then we know two lines will be perpendicular, and then if they are, we know that they will be a right-angled triangle. Okay, there we go. So now that we know what to do, we've talked it through, let's do it. So the slope of PQ is y2 minus y1 over x2 minus x1, and P and Q are my points, so I'm just going to cover up R for a second. So I've got 0 minus 3 over 0 minus 3. 0 minus 3 over 0 minus 3. So that's -3 over -3, and anything over itself, of course, is 1. So the slope of this line is 1. Okay, now let's do the slope of QR. So QR is y2 minus y1 over x2 minus x1. And QR, I'm going to cover that point up. So now I've got -4 minus 0 over 4 minus 0. So let's see here. That's -4 over 4, and -4 over 4 reduces to -1. So are these two the negative reciprocal of each other, or are these two, do they have a product of -1? They do. Let's take a look just so that you can see in case you're a visual person. So here I've got the point 3, 3. Let's put some scaling like we always do, at least one number on each axis. So that's point P. And then I've got the point 0, 0, this Q. And then I've got the point 4, minus 4. 1, 2, 3, 4. So clearly I can see that makes a triangle. And I just found that PQ, and QR meet at 90 degrees, which looks like it. We can't assume it, but we can see that that clearly doesn't. That clearly doesn't, but that clearly could be, and when we test it, we see. Now here's something that you could do. If you want, you could, well, first let me answer the question. Show that this is a right-angled triangle. So you would say, since the slope of PQ is, oh, pardon me, actually, I wouldn't say slope. Let's say it this way. I would say since PQ is perpendicular, the line PQ, line segment PQ is perpendicular to QR, therefore, P triangle, PQR, is a right triangle. There we go. Now we've answered the question. So now let me just take a step back for a sec. Actually, let me just fix this here a little bit better. When you're doing a question like this, if you want, it's a good idea to plot the points first, actually. In other words, do it the opposite way that I did it just now, so you can see, wait a minute. It looks like this is the right angle, so I'll find the slope of those two, as opposed to finding them all and then just checking. So that's a way that you could, with intelligence, zero down into what is more possible to check first. Okay, now let's take a look at this one. This one says the vertices of a right triangle. So here we don't have to prove it's a right triangle. They tell us it's a right triangle. So let's see here. I've got 2, 2. So let me put 2, 2 here. And that's, let's call this A, B, and C. You can always name things if they don't, they being the people giving you the question. So in this case, me, if I give you this question and it's not labeled, you can label it with vertices. Remember, vertices always have capital letters. 5, 2, 4, 6, 2, 4, 6, 8 is B, and then C is negative 2, 2, 4. Okay, so when we do this, we can see that this is most likely the right angle, right? That doesn't look like a right angle, and that sure as heck doesn't. This is probably the right angle. So if that's the case, and we're looking for the area of a triangle, and we know the area of a triangle is equal to 1/2 base times height. You might have learnt it as base times height over 2. Of course, that's the same because that's a 1/2 base times height. So let's see here what that gives us. The height would be this, if this is the perpendicular. And if you need to, twist the triangle around so it looks like there's the height and there's the base. So the height, we need to know what that length is. And the base, we need to know what that length is. So we need to know the length of AC, so these two, and we need to know the length of AB, these two. So this length we don't need to bother figuring out. Let's go back. So we need to find the length of AB and the length of AC. So you might be thinking, well, how do I know what to find out? Well, or how do I know what to plug in? Well, if they don't give it to you, then, like here they gave it to us. If they don't give it to you, the information, then they've given you enough information to find it. Just think about how I've walked you through this. And of course, part of the reason, if not the reason I'm making these videos, is so that you can replay them and listen. It's not like you're in class with a teacher and they said something which was probably fantastic, but it was in one ear out the other, or you just can't remember it exactly. You read your notes, you go home, you're like, oh my gosh, what the heck did my teacher mean? Well, here you can play it again and again. So here we need to find the length of AB. So the length, I'm going to do it down here so we have some room. Length of AB is equal to x2 minus x1 plus y2 minus y1 squared equals, oops, right on the table. Okay, so here AB. So x2 is 5, x1 is 2, and then y2 is 8, and y1 is 2. So here I've got 3 squared plus 6 squared, root 9 plus 36. And that is, of course, 45, which, of course, is not a perfect square, 45, but we know it's 6 and a bit close to 7, because the root of 49 is 7. Now let's find the length of AC. So I'm going to do it over here. The length of AC is equal to x2 minus x1, y2 minus y1. Make sure the root goes over it. And then I'm looking at AC. So I've got here negative 2 minus 2 and 4 minus 2. So that's minus 4 squared plus 2 squared. And that's 16 plus 4, which is root 20. All right, so root 20. So now let's see here. I'm going to break these roots down because these are both entire roots and I need them to be mixed. So root 45 is 9 times 5, which is 3 root 5. And root 20 is 4 times 5, which is 2 root 5. So now let's plug them into here because I now have my half, my base is AB, which is 3 root 5, and my height is 2 root 5. So that gives me 1 times 3 times 2 is 6 over 2, and root 5 times root 5 is root 25. So I'm just going to go over here because I'm running out of space. 6 over 2 is 3, root 25 is 5, and 3 times 5 is 15. Now, they didn't give us units, so we're going to write units squared. If they don't give you units and you're dealing with distance, then just use units. And if they're giving area, if you're looking for area, you'll use units squared. And of course, if you're using volume and they don't give you the units, you just write units cubed to denote that you understand what dimension you're working in. This is second dimension, length and width, 2 dimensions. Okay, there we go.